called as the self-inductance. And I hope you are very familiar or you have understood the definition of inductance. It is the property of the circuit which opposes the current in the circuit. So let us take, you have a coil and it is connected to a battery and a plug key. So it has n number of turns and the current is I. So the flux induced is directly proportional to the change in current. The number of turns times the flux is directly proportional to current. We know that when the current is increasing, हमें पता है magnetic field is directly proportional to current. When the current is increasing, then the magnetic field is also increasing. When the magnetic field is increasing, then the flux will also increase. So this I can directly write it as flux is directly proportional to the current. So we have it as N phi is equal to L into I, where L is the constant of proportionality called as self-inductance. So L is the constant of proportionality, where L is the constant of proportionality and it is called as self-inductance. So it is the constant of proportionality which is called as the self-inductance, which is actually defined as, so if I is equal to 1 ampere and number of turns is equal to 1 turn, then L is equal to phi. So the self-inductance is equal to the flux induced in the coil of 1 turn with 1 ampere. So with this you can also write it as the induced EMF is given by minus d phi by dt, which is equal to E times minus d by dt of n phi is equal to Li. So if you take for n turns, so L into I, which is equal to minus L times di by dt. So the EMF induced is equal to di by dt. So this is very important expression for the induced EMF.